Students, after a short break, we can move to next chapter in physical chemistry, photochemistry. I think you have introduced this term in lower classes. Anyway, this chemistry, look at the word photochemistry, like organic chemistry, inorganic, physical, biochemistry, like a new branch. But don't think that this chemistry is something new, which has been with us in our universe when there was light. But we understood this chemistry very late. Okay. In this chapter, very small chapter, we are discussing some introductions, some beginning topics. Later, when you do the post-graduation, PhD, research, obviously you will come across these topics. And you have been learning spectroscopy, and I will tell you, spectroscopy also photochemistry, because there are also light involved. But spectroscopy is learned as a tool to understand the chemistry. But the principle behind the spectroscopic techniques is nothing but photochemistry. Therefore, the topic is very interesting, fascinating, and enthusiastic. I recommend you not only watch my videos, but read more. Your device, mobile device, will help you to explore more on these topics. Okay, let us begin. What is photochemistry? The question is very important. What is photochemistry? Is photochemistry around us? Can you spot any photochemical reaction around you? Tell me. You just think a while. Any photochemical reaction around you? Please think. Anybody? Okay. When I tell you the examples, you will wonder, are there photochemical reactions? Okay, wait. What is photochemistry? It is the chemistry dealing chemical change which involve light. Okay, that is either light absorbed or emitted during the reaction. Light is absorbed or emitted during the reaction. That is photochemical reaction. Okay. The next word, what is the counter word? That is called thermal reaction. Normal chemical reactions are thermal. What is that? Where heat absorbed or emitted. Okay. Thermal reactions also called dark reactions. Dark reaction doesn't mean that reactions carried out in the dark room. Now, even you are doing a reaction in the light room, even in the presence of sunlight. Suppose you are doing an experiment in the laboratory, we will switch off all our tube lights. We cannot do it in the dark. But that reaction is considered as dark reactions. You know, our laboratory, our volumetry, or gravimetry, or mixture analysis, all are dark reactions or heat reactions or thermal reactions. Not because it is done in that dark room, but because during that reaction light is not absorbed or light is not emitted, but heat is absorbed. Sometimes you will heat, you will boil. Suppose when you titrate oxalic acid against camphor, you will heat the warm the oxalic acid. Okay, but because where heat is absorbed. Similarly, when you do some experiments, you not only you will get the products, but also you will get the heat energy. But if you get the light energy, that's a photochemical reaction. Okay, if you get something light. If you have any such situations, that is for. There are some photochemical reactions we are doing. Those are, that term flame analysis. Flame analysis heats and light, because some light is involved. Where heat is involved, light is involved. Okay, light is involved because you are seeing color, means color because of the light. Okay. There are fluorescence reactions are there. Okay, therefore, we have two types of photochemical reactions. We have two types of photochemical reaction. Photochemical reaction, two types. One is light gives chemical reaction, because light absorbed and reaction happens. Second is reaction gives light. Reaction gives light. This is called the chemiluminescence. Chemiluminescence. This is called fluorescence or phosphorescence. Phosphorescence. This is called fluorescence or phosphorescence. What is chemiluminescence? Because chemical reaction gives luminescence, light, glow. Chemical reaction gives luminescence. This is fluorescence or phosphorescence. Okay, light gives the reactions. Yes. Now, examples of photochemical reactions. You can do some examples. One is some example: photosynthesis. Second, formation of ozone. That is 3O2, light absorbed 2O3. Here you know carbon dioxide plus H2O, 6 carbon dioxide plus 6 H2H nu, C6 H12O6. Okay. Then photochemical smoke, a new type. Fourth, formation of vitamin D in the body. You know, when we expose to early morning or sunlight, vitamin D will be developed in our body. This is a beautiful example for photochemical reaction, because light is absorbed by our body components, then they are converted into vitamins. Then I will tell you one example, one amazing example. Treatment of jaundice. Dear students, have you heard any occasion that is newborn baby? Let me check the video. Okay. Newborn babies, suppose your brother or brothers or anyone in your family gave birth to a newborn baby, and you might have heard that there is some yellow in the baby's eye. Therefore, baby is kept in the isolation ward, light ward. Because this yellow, because of the jaundice, that has been treated in the form of light. Because of the light, that molecule get decomposed. That is why before beginning of these techniques, in the earlier period, the baby was exposed to early morning sunlight. Our mother or the eldest one in the family will carry the baby in the arm, in the hands, and will expose to the sunlight for some time as a treatment of jaundice. Okay. Then another is firefly. Firefly is another example. Firefly. Phototropy, that is bending of plants towards the light. Then photography. Okay. Then photodegradation of plastics, something like that. Certain molecules, when you keep outside, it will be photodegraded. Okay. Fine. These are some examples. See how many photochemical reactions are around us. But we have discovered these photochemical reactions recently. We only understood the involvement of light in this reaction very recently. Okay. Therefore, what is a photochemical reaction? Reaction which absorb or emit light. That is the simplest definition. Okay. Now, difference between photochemical reaction and thermal reaction. Photochemical reaction and thermal reaction. Difference between photochemical reaction and thermal reaction. Photochemical reaction and thermal reaction. Here light involved, here heat involved. You know, every reaction is accompanied by energy. Every reaction taking place, some exchange of energy. This energy may be photochemical. The energy may be involved in the form of light or heat. If energy is involved in the form of heat, they are called thermal reaction. If energy is involved in the form of light, that is called a photochemical reaction. Okay, here, therefore, here energy involved in the form of light. Here energy involved in the form of heat. That is light absorbed or emitted. Here heat absorbed or emitted. Okay. Here electronic excitation occurs. Here electronic excitation. When light energy is absorbed, electron is absorbing the quantized form of energy and they are excited and de-excited. That causes the reaction. Fine. But here vibration or rotation or translation, that is collision occurs. This is how this vibrational motion, rotational motion, or translational motion occurs. Therefore, when you heat the sample reactants, there will be more collisions, more effective collisions. That is more effective translational motions. Translational motions happens. Okay, vibrational, rotational, and translational motions occurs. But here electronic excitation is happening. Now, this reaction always happen. Maybe during the reaction, increase or decrease of free energy occurs. Increase or decrease. But here only decrease in free energy. Sorry, decrease in free energy. A spontaneous thermal reaction only decrease in free energy happens. But here increase or decrease is a very controversial. You know, when I was doing PhD in the university, one of our professor was taking class, a seminar, he just mentioned that there is some reaction. Some reaction with increasing free energy. Therefore, other professor, an organic professor, raised hands. He objected. That doesn't happen, and there was a controversy. And we were the students. We just watched. But later, when I read the photochemistry in detail, I noticed that. But that professor who said that there is increase in there is an increase in reaction where free energy increases, but he cannot cite the example or specify the reason. He cannot. If he would have said this, he would have won that debate. I think such a situation. I still remember that situation in that conference hall anyway. Okay, anyway, there is a photochemical reaction where increase or decrease in free energy. That is delta G negative or delta G positive. It may be delta G negative or delta G positive. Okay. Now the final points 1, 2, 3, 4. Suppose the final point depends on light, depends on heat, depends on heat. Now I will show you the graph. Okay. Suppose you have a graph like this. Reaction coordinate, reaction coordinate and energy. Reaction coordinate and energy. This is our thermal reaction, a reactant, a product. It goes like this. This is thermal reaction. Okay, where delta G negative, always delta G is equal to negative. Yes, but same reactant, if you undergo the photochemical reaction, okay, you give a supply light, H nu, photon, therefore the reactant will be excited, R star. Excited. Reactant absorb the light, plus H. Now, it undergo a reaction, it needs, this is activated complex, and give a product. Suppose you write a product. Okay. Look at the products. Okay, obviously this will be an activated product. Look at this product. This is the original reactant you have taken. The energy of this photochemical product, the products of photochemical reaction, is still more energy than this reactant. When you compare these two energy, delta G is positive because it has more energy than this. Product has more energy than reactant. Therefore, this reaction has a delta G positive. Okay? This is what a reactant absorbs the light. But in a thermal reaction, this is the route. Photochemical reaction, it can be the route. Okay. Yes, I think this video is clear. We can continue. Thank you for watching. Have a nice day.